The robot, whom we call Sir Tony, is based on a crunch build design that uses a standard drivetrain, active roller intakes, and an arm. We added an inertial sensor to assist with accurate navigation. Because we are working remotely from home, we were only able to set up a quarter of the field as depicted in this image. We started learning with block code and then converted the code to text. This was a great way of learning how to use text-based code. Throughout our code, comments describing our decision-making are hashtagged. In the first part of our code, we set two variables for values that are used frequently in the program: wait time of 5 seconds and a full rotation of 360 degrees in order to make the program more efficient. The arm lifts and lowers to the correct height for the goal with 360-degree rotation. The robot has a preloaded ball and drives forward. It lifts the arm, releases the ball into the goal, and lowers the arm. A spin for forward code lifts the arm, and a spin for reverse lowers the arm. A spin for reverse code for the intake releases the ball. In order to give the robot sufficient time to release the ball, we increase the number of rotation degrees to 800. In the next part, the robot drives backwards, turns right, drives forward, and starts spinning the intakes while driving so the ball does not get pushed away when the robot approaches and picks it up. The turn velocity code was more effective in turning the robot precisely than the turn 4 code. A percentage was inputted in the turn velocity code to indicate how fast the robot should turn. A lower percentage made the robot turn more slowly. Wait time was coded in order to determine how far the robot would turn. A shorter wait time meant the robot turned less. A spin for forward code for the intake picks up the ball. In this section of the code, we use a conditional logic statement that if the intake is finished spinning, then the robot should drive backward and then turn right. The robot then drives forward, lifts the arm, releases the ball into the goal, and lowers the arm. In this portion, the robot turns right, moves forward, picks up the next ball with the intake spinning, moves backward, turns left, lifts the arm, drives forward, releases the ball, moves backward, and lowers the arm. In order to give the intake sufficient time to intake the ball, the number of rotation degrees was increased to 1,000 in the code. For the final sequence, sequences used before in the code were repeated. The robot turns right, drives forward, spins the intakes, picks up the ball, turns right, drives forward, lifts the arm, releases the ball, lowers the arm, and drives backward. Every drive forward and drive reverse code was inputted with precise measurements in inches taken with the measuring tape on the field. This section of the code shows the programming for the inertial sensor. The total time for the autonomous program is 55 seconds. Thank you for watching.